What's the formula for the derivative of ln u? Guys, is this not on your worksheet? Yes, okay. Derivative of ln u. U prime over u, right? Guys, you need to have this memorized, okay? That is the same thing as 1 over u times, and remember, this is a numerator and it can bounce out. U prime is really du dx. So if you wanted to, you could bounce that out, okay? What is the derivative for log au? It's still u prime over u, but there's this extra thing. Do you remember? ln of a, and it goes on the bottom, okay? So this has the same situation. This is du dx on top, so it could bounce out, all right? What about e to the u? What's the derivative of e to the u? E to the u du dx. Do you remember that? E to the u du dx, all right? It's got a little sing-song to it. E to the u du dx. That's it. That's all. That's the whole song right there. Okay. What about a to the u? A to the u, and then do you remember it has this extra part in it? ln of a, and then du dx. Okay. So e to the u du dx and a to the u du dx, it just has this extra ln of a. And honestly, this actually has the same thing. It has an extra ln of e. But guys, what is ln of e? It's just 1, and so we don't put it. But if you wanted to put it, that would be fine, okay? I would wonder if you knew what ln of e is, but and I actually took off a point too. But it is really just 1. All right, I'm going to pull this out. Let's go ahead and do some polynomials with this. So if I know this is a formula, what would be the derivative of ln of x squared plus 1? 2x over x squared plus 1. What would be the derivative of log 5x squared plus 1? 2x over x squared plus 1, but it has an extra what? ln of a, but what's my a here? 5, beautiful. Okay, what's the derivative of e to the u? What do you do first? You copy it, and you multiply it by du dx. What the heck is du dx? Cosine, very good. It's the derivative of your u, which is cosine x, and you would just multiply this together. And you can't really simplify it more than that. All right. What's the derivative of 12 raised to the 5x? A to the u, you copy it, times ln of a. What's my a in this problem? 12. What's the derivative of my u? Remember, this is my u, my exponent. What's the derivative of my u? 5. And you actually can't simplify it more than this. You think you can multiply the ln of 12, but you can't, because 12 belongs to the ln family. And you just leave it like that. And then finally, guys, what's the difference between 12, the derivative of 12 raised to the 5x, and the derivative of 12x to the 5th? Okay. This one is an AU problem. Yeah, this one is not a, this one's just a regular power rule. Yes. Yeah, it's not an AU problem. So the answer to this one would be nice. Okay, so you guys see the difference, because sometimes it gets confusing. They look the same, but if you have an x in the exponent, you have to do AU. If the x is in the base, then you can use the power rule. All right, knowing all of that, let's go back to tangent lines, okay? Guys, pull out your homework from yesterday. Did you guys have any questions on that? I can answer that now if you like. What questions did you have that you couldn't get your answer to match on your homework last night? You guys are good? Okay. All right, then let's move on. We're going to do a tangent line problem here. And what I want to do is I want to figure out the tangent line for this function, x to the 6 at x equals 1, okay? If you go to your calculator and you graph x to the 6, what you'll see is that it looks a lot like x squared. It looks a lot like x squared. It's just a little flatter on the bottom, okay? But it looks a lot like x squared. And if I want the tangent line at x equals 1, what you have to understand is that if I went to 1 here, if x is equal to 1, my y value here, so my y value here, okay, would be 1, right? You guys good with that? I would plug in 1 here. 1 raised to the 6th power is 1. Okay, and if I wanted the tangent line there, all I would do is I would draw a line right there. I'd get closer and closer and closer to the graph until it looked like a line. I would extend that line, and that is the tangent line. Okay, make sure you understand. The graph or the equation for this red line is y equals x to the 6. Here, let me put it in red so that we're consistent. The equation of this red line is y equals x to the 6. The equation of this green line is not y equals x to the 6. You're good with that? Let's write the equation of the green line. How do you write an equation of a tangent line? What do you need? Point and a slope. What point am I looking at here? 1, 1. What's my slope here? It's the slope of the tangent line. What's the slope of the tangent line? Derivative. Okay, so this is 6x to the 5th, but I need a number here. So what is my x going to be here? 1. So guys, be careful. It's not 6 times 1. It's 1 raised to the 5th first. Do you guys see that? Exponents before multiplication. So what's 1 times 1 times 1 times 1? Okay, so that's 6. Everybody good with that? So, technically f prime of 1 is 6. All right, I've got all numbers here. Let's write my equation of the tangent line. It is y minus y is equal to the slope times x minus x. All right, so this equation right here, this green line is actually y equals 6 times x minus 1 plus 1. Are we all in line with that? Okay, so if I wanted to find this blue point here, I would plug in 1 right here to this x to the 6 equation. But if I wanted to find an approximation of this, so let me figure out, oh, well, okay, we're stopped here. Okay, if I wanted to find out what, is this on your paper? Do you have 1.01 raised to the 6? No, what do you have? Something, say it again? 1.12 raised to the 6, you have that? Okay, if I wanted to know what 1.12 raised to the 6 is, do you agree? The real value would be, if I come over here, find 1.12, come up to the red line, okay, and wouldn't 1.12 raised to the 6 be this y value right here? Isn't this 1.12 raised to the 6? You guys agree with that? Okay, but let's say that I can't do that in my head, or I don't have a calculator, because what's 1.12 raised to the 6? Nobody can do that in their head, right? Let's say you don't have a calculator. You can use this tangent line to approximate it. What am I saying? I'm saying instead of plugging 1.12 into this red function, plug 1.12 into this green function. And do you see how far apart they are? Okay, yeah, they're not that far apart. I might get pretty close if I don't have a calculator. So let's try it. Here is my green function, okay? Plug in. Now, is this going to be my x plugging into here, or is it going to be y plugging into this green function? It's my x, right? So plug in where you see your x. Plug in 1.12. Okay, plug in 1.12 there. Okay, and this, if I don't have a calculator, I could probably still do it. 1.12 minus 1 is 0.12. You agree with that? 6 times 0.12 is 0.72. So this is going to give me y equals 0.72 plus 1, which is 1.72. So what is this saying? This is saying that if I come here to 1.12, come all the way up here, this red dot right here, is it this red dot? This red dot right here is actually 1.72. And how far away is it from 1.12 raised to 6? Well, let me see. Go get my calculator. Okay, put in 1.12 raised to the 6. Not great, but not too bad, right? So the real value for 1.12 raised to the 6 is equal to 1.973822. Okay, not a great approximation, but not bad. Let me write here, guys, just to make sure you understand. This is an approximation. Okay, this is the real value. This one I did on a calculator. In your test, I will ask you, what is the error? Well, I'll ask you two things. I would say, is it an under approximation or an over approximation? Okay, and what is the error? So the error would be you take one and you subtract the other. So I'm going to subtract 1.72. Okay, and the error is just always the absolute value of this. So if it's negative, don't worry about the negative. It's just the absolute value. So my error is 0.2538, and I'll tell you how many decimal places to go. Of course, if I don't, you always go 3. So I'm going to say the error is actually equal to the approximation minus the actual. That's the formula. Do I have that on your paper anywhere? Okay, good. And that is equal to 0.2538 or something like that. That's what I remember, but 0.25, oh, nice, 0.2538. Okay, all right, that's the error. What if I asked you, is the approximation an under approximation or over approximation? Can you tell me? It's an under approximation. So you'll say under approximation, and I will ask you to justify. And the way you justify this is this. Now, remember, this is a tangent line, okay? There's something cool about tangent line approximations. If you ever have something that's concave up, your tangent line actually, it's always like this. Your tangent line, like draw it, it's always going to be underneath your actual. Okay, so this is my actual curve. Okay, if I draw a tangent line, it's always going to end up underneath. So you're always going to have an under approximation if you're using tangent lines. Okay, if I'm concave down, guess what? If I do a tangent line, it's always going to be above. Okay, like one time I tried to trick it. Look away. It's still above. Like you can't even, look, you can't even trick it. Okay, so if it's concave down, your approximation is always going to be bigger than your real curve. Does that make sense? If it's concave up, your approximation is always going to be what? Smaller. It's always going to be under approximate. Guys, when I'm concave up, what did I say that that's my second derivative? A few months ago, I said my second derivative is what if I'm concave up? Positive, greater than 0. If I'm concave down, my second derivative is what? Negative. Oh, I'm so sorry. I didn't, you guys probably didn't see that. Okay, so this is concave up, guys. Can you guys see that? And so your tangent line is always below, okay? And then this is concave up, so your tangent line is always above. Can you guys see that? Okay. All right, so guys, the justification here, if you're below, is that your second derivative, okay, at that x, and it doesn't matter if you put the 1 or the 1.12 because they're both really close to each other, okay? So I'll put the 1.12 is positive, is that right? Is positive, let me check. Yes, okay, so everybody good with that. So that's gonna be your justification. The second derivative is positive or negative. You'll have that on your test. Now, let me talk to you guys about this. Now, some of you guys are like, wait, don't you have to calculate the second derivative? You can if you want, okay? Come in here, you don't have to, but look at this. If I take the second derivative of this, what is it? Isn't it 30x to the 4th? Okay, and what is my x value? Is it 1 or 1.12? It doesn't matter. You could put 1 or 1.12. It doesn't matter. You could just put 1. That's easier. Okay, is that positive? Yeah, and so you can like calculate it if you want and say it is positive, but you probably want to stay awake, Maddie, to understand this. So you want to be, you can calculate if you want, but you can also know that if you have an under approximation, your second derivative is positive, okay, at that point. Not always, but at that point that you're looking at. What other approximation do you need to have on your notes? What does it say? Okay, 0.9. All right, so here's a question. What if I'm trying to find, oh, it's not for me. Okay, what if I'm trying to find 0.9 raised to the 6? Okay, so let's look at this. Do you agree that this is x raised to the 6, right? So if I want 0.9 raised to the 6, wouldn't I just come right here? 0.9 is right here, okay? And guys, if you understand these graphs, then this is going to be easier for you. If you don't understand the graphs, you can memorize what to do, but things are going to be a little bit harder, okay? So 0.9 raised to the 6, do you agree that it's the red, it's that red dot right there, right? If I went to the red line and I punched in 0.9 and I put in the 6, it'd be right there, 0.9 raised to the 6. It'd be this y value, whatever this is, 0.9 raised to the 6. But can you do that in your head? Can you do 0.9 times 0.9 times 0.9? Pretty hard, okay, without a calculator. And even if you had a piece of paper, it'd be a long time before you got to 0.9 times 0.9 times 0.9 times 0.9, so on. All right, but what if I use this green line, okay, to figure out what 0.9 raised to 6 is? If I estimate it, look at where it is. It's not that far below, right? It's not that far below. So let's try it. This is my green line right here. Instead of plugging in 1.12, let me plug in 0.9. Let's plug in 0.9. So here we go. Let's figure out what 0.9 raised to 6 is. About. This is called the tangent line approximation. What am I going to put into that x? 0.9. Okay, minus 1. Okay, now this you can pretty much do in your head. What is 0.9 minus 1? Negative 0.1. What is negative 0.1 times 6? Isn't that negative 0.6, right? And then I'm going to add 1 to both sides. So y is that 0.4? Okay, so I'm saying about 0.4. Okay, so what is this y equals 0.4? That is an approximation. So let me write that down. That's approximation for 0.9 raised to the 6. Okay, so guys, if you're on a date and your date says, what's 0.9 raised to the 6? Okay, and you don't have a calculator. Okay, you can just be like, hold on, do a tangent line. Okay, because you don't have a calculator. Put in 0.9 right there into that tangent line, and you'll impress your date. You'll be like, oh, I think it's about 0.4, okay? And then go look on the calculator and see how close you are, okay? Go to your calculator, put in 0.9 raised to the 6. Let's see how far we are off. 0.531, not bad. Okay, I mean, I wouldn't send anybody to outer space on it, okay? But if I were estimating your grades, what'd you say? No, I'm gonna show you the second date in a second. This one will probably just get you over the hump, okay? Now the second date, you're gonna have to get a little bit closer than that. All right, this one right here is gonna be the real value. So I'll say the actual value is equal to 0.531441. Okay, let me ask you guys this. Is this an under approximation or an over approximation? Under approximation. Okay, so if I ask you, you would say it's an under approximation. If I ask you to justify that for me, can you justify it for me? Because the second derivative is what? Positive. Very good. Okay, 2 ways you can do it. You can actually find the second derivative, or guess what, guys? Over here, am I concave up or concave down? I'm concave up. Do you guys see that? Even the picture shows me that I'm concave up. So the second derivative is positive. All right, let's do another problem. Did I answer everything on that question, by the way? Okay, so do you have one with a square root? Okay, so let's go find a square root problem. Then another name for this is called linear approximation, just FYI. I'm calling it tangent line approximation, but sometimes you call it linear approximation or linearization. Those are all the same things. All right, here we go. I need a tangent line. So what 2 things do I need? A point and a slope. What is my point here? What's my x value? If my x value is 16, what's my y value? 4. Okay, you guys might want to write this down if you're not writing. Okay, then you want the slope. This is the slope of a tangent line. Okay, so how do I get the slope of a tangent line? The derivative. Okay, when I say derivative, you say slope of a tangent line. There it is. Okay, so we're going to get the derivative here. Now you can't get the derivative of the square root thing. Okay, you have to rewrite it. So this is x to the 1/2. So the derivative is 1/2 x to the negative 1/2. I'm going to have to plug in an x here to get a number. But guys, this is meaningless. When you have something raised to negative 1/2, nobody knows what that is except for Einstein. Okay, nobody knows what that is. And he's dead. And so what you want to do is you want to move this to the bottom so you have a positive exponent. And guys, what is x raised to 1/2? What is that really? Square root of x. Okay, now you can plug in. All right, what am I going to plug in for my x? Because I need a number. What is my x value here? 16. So do you see that this is 1/8? Is everybody good with that? Because this is really 16. All right, guys, let's do it. Y minus y is equal to the slope times x minus x. All right, that is the equation of the tangent line. Okay, so let me show you what I just did. Okay, I have this function, square root of x. This is my function right here, square root of x. Okay, then I went to this point, 16,4. So here's my point 16. Okay, I went to it and I said, you know what? I'm going to draw a tangent line right there. So I got the point and I made a straight line. Okay, I'm saying this is my tangent line. So I have 2 equations up here. Okay, my red line here has an equation of y equals square root of x. My blue line here has an equation of y minus 4 equals 1/8 x minus 16. Is everybody good with that? So if I want a point on my blue line, I would plug into this blue equation. If I wanted a point on my red line, I would plug into the red equation. You're good so far. All right. So what I want to do is get an approximation. And is it 16.2 that you guys need to approximate? The square root of 16.2? Okay. So if I want the square root of 16.2, you agree, here's 16.2. Go plug it into the square root of 16.2. And that would be this value here. But who in the world can do that without a calculator? Okay. Not me. Okay. So what you could do is you could actually, he's dead. What you could do, you could actually stick it into this blue equation instead. Okay. Now you don't put in square root of 16.2. You only put in 16.2. Does that make sense? Because that's your value for your x. You put it in right here. So that's going to be y minus 4 is equal to 1/8 times 16.2 minus 16. What is 16.2 minus 16? 0.2. So that's 0.2 over 8. You add 4 to both sides. That's going to be your y. I'm going to cheat. I'm going to get my calculator. You can use your calculator on your test anyway. So 1.2 divided by 8, that's 0.025. So what I get is 0.025 plus 4. And so my approximation is 4.025. Now, what am I saying? What is this an approximation of? What am I approximating? What do I think that's about the same as what? The square root of 16.2. That's my approximation. Let me go to my calculator and see how far off I am. Let's see. The square root of 16.2. Not bad. Not bad. This is the second date. This is going to work, okay? 4.025. I mean, it's almost exactly the same. Do you see that? If I wanted the error, I would subtract 4.025 from it. And look at that. The error is so small, it looks like a cuss word. Look, you can't even tell what number that is, okay? This means you move the decimal over by 5 places. So if I'm here at this decimal place and move it over 5, it's going to be, the error would be, and I don't think I asked you for the error on this problem, but it'd be 0.0007764. And I'll tell you on your test how many decimal places to go. But make sure you understand how to read this on your calculator, okay? All right, that's your error. Here's another question. Is this an overestimate or an underestimate? Okay, let's look at the real value again, 4.0249. Okay, it's an overestimate. Do you guys see that? Because this number is bigger. So you'll say overestimate. Okay, I need you guys to help me justify this though. Because, okay, which derivative do I look at? The second derivative, and is it positive or negative? Negative. Is everybody good? Do you see why it's negative? Because it's an overestimate, okay? Use what God gave you guys. Use your hands because it really helps you, okay? And if your second derivative is positive, it'd be an underestimate. If your second derivative is negative, you guys see that concave down, you're an overestimate. You also already knew it was concave down. How? Did you look at your graph? Do you see that red graph? It is concave down. Do you see that? And that's another reason you knew your second derivative was negative. All right, what other number do we need to estimate here? What's your next one? 48.8. Okay, so what if I want the integral, the square root of 48.8. Let me, you guys will have this on your test, something like this. Did we do the 16.2 already? Okay, so here's the 48.8. On your test, I'm not going to give you a function, okay? Because in real life, to impress your girlfriend or your boyfriend, you're not going to be like, what's the function? Like, that would be embarrassing, okay? You're going to have to find your own function, okay? So right here, use the tangent line to approximate the value of 48.8. What you do is wherever the funky number is, okay, that's going to be your x, okay? And see, do you see your funky number is 48.8? So that's going to be your x. So that is how you write your function, okay? If you go back to the original question we had, remember we had 0.9 raised to the 6 or something like that, okay? Was it 0.9 raised to the 6? Your function was, and I gave you the function there, but do you see your funky number here is your 0.9? So that function would be x raised to the 6. You guys see that? How to get your function. The funky number is always your x, okay? So that is your square root of x. So then you need a point, and you need a slope, and you need a tangent line, okay? Remember, on your test, I'm not going to give you the function. So you have to figure out your function. Guess what? I'm not going to give you your point either. Okay, so you have to figure out what point to put in. Okay, here's the thing. Here's your x. Do you see it's 48.8? Okay, but you don't want to put in 48.8. I mean, I'll show you why. Because if you put in 48.8, how do you get your y? Well, your y is the square root of that. Well, that's so hard to begin with in the first place. Okay, so what you want to do is round to a close number that you could actually get the square root pretty easily. 49. Do you guys see how to do this? So you can pick a nice number. You get to pick the point, okay? So why would you pick 48.8? That's so hard to do. So pick 49, and what's the square root of that? 7. The number one wrong thing students do on the test is they write 7 and 49. Why is the x not 7? Yeah, because if the x were 7, then this would not be 49. This would be what? Square root of 7. Does that make sense? Like, this is not, that wouldn't be right. Okay, now what do you get for the slope? If I know the function, I know the point, can I get the slope? Take the derivative. You're good? So this is actually equal to x to the 1/2. If I take the derivative, I'll get 1/2 x to the negative 1/2, which is really, we already did this, 1 over 2 square root of x. Now I need a number here. So how do I put in, what number would I put in for x? 49. If that's 49, what's the slope? 1 over 14. Let's write the equation. You guys can do it. Let's go. Y minus y is equal to the slope times x minus x. Y minus y is equal to the slope times x minus, oops, that's not my x. X minus, oh yeah, that is my x. X minus x. Okay. I'm trying to, though, get the square root of 48.8. So let me show you what I've just done. I basically, okay, so if you can understand what we've done, it helps you a lot. I've basically drawn this function y equals square root of x. And I said, I have a point here, 49.7. So there's my point, 49.7 right there. And I went there and I drew a tangent line, okay? And I said, I want the square root of 48.8. So what that means is I would plug into the red function at 48.8. So right here, 48.8. Is that 4? Yeah, I'd plug into our red function. So I would be right there. But I can't do that in my head. Who can do the square root of 48.8 in their head? Nobody. Okay, Parker, put your hand down. Okay, so right here, if you put 48.8 into your green function, does that make sense? My green function is y minus 7 equals 1 over 14, x minus 49. It's right here. It's pretty close. It's actually above, so let me pull it up a little bit. It's pretty close to the red one. Not exactly, but it's pretty close. So let me see how close I can get. So I'm going to plug into this tangent line, but plug in 48.8, so that's 1 over 14. What's 48.8 minus 49? Is that negative 0.2? Okay, so I have y minus 7 equals negative 0.2 over 14. Hold on, I'm going to put that in my calculator. I'm getting 0.0142. Do you guys see that? So y is going to be equal to, and you subtract that from, no, you add that. You add that with 7. So I'm getting 6.98574, blah, blah, blah. Okay, you guys see that? That's my approximation for what? What did I approximate? The value of square root of 48.8. So this is an approximation for the actual. The actual was the square root of 48.8. Let me go to my calculator and see how far off I am. Here we go. The square root of 48.8 is equal to, whoa, guys, whoa, check that out. This is like 6.9857, basically, okay? Not that far off, right? Using a tangent line approximation. Okay, now, does it ask if it's an underestimate or an overestimate or anything like that? No, then we're done with this problem? Okay, let me just, I wanted to point out something. What if I hadn't picked 49 here, okay? What if I had picked, let's say 9? Would that have been a good approximation? No, do you see that? So that's why you want to pick a number that's kind of close to this number. Does that make sense? Or else your approximation is going to be pretty far off. Okay, it'd still be an approximation, but it would be a bad approximation. All right, let's do one more problem. This one right here, 4.1 raised to the third. And this is how your test is going to look. I'm not going to tell you the function. I'm not going to tell you the point. You have to figure out your point and your function yourself, okay? So we're at 4.1 raised to the third. Guys, which one's the funky number? 4.1, make that your x, okay? So your f of x or your y is going to be x raised to the third. You guys see that? You have to make up your own function. I also need a point, and I also need a slope, okay? What's a good point close to 4.1? 4. 4 is a great point, okay? If I plug in 4, what do I get for y? No, keep trying. Because here's my y right here. It's a new, yeah, you're using the wrong function. So, right, you have to use your new function, 64, okay? And you'll have a calculator, so if you're not sure what 4 times 4 times 4 is, you can do it in your calculator. What's the slope going to be? Very good, okay? But I need a number. What's my x? 4. So guys, remember, exponents before multiplication. So please don't multiply the 4 and the 3. It's got to be 4 times 4 first, okay? Then multiplied by the 3. Did you guys get 48? Okay, nice. All right, write your equation in the tangent line. Y minus y is equal to the slope times x minus x. All right, so if you were really smart, you could do this without a calculator, 4.1 times 4.1 times 4.1. But who can do that, okay? So what you can do is just estimate it using this equation of the tangent line. Everywhere there's an x, okay, put in 4.1 instead, okay? And let me show you mathematically or graphically what you just did. You just said that there's this function here called x cubed. Okay, there's a function x cubed, okay? And you want to know when you're at 4.1 what that value is. It's right here, okay? But that value is really hard to get. So instead of going right there at 4.1, you back it up a little bit and you look at 4 and you draw a tangent line right at 4, okay? And this tangent line at 4 is this equation right here. That's this equation. And so instead of plugging in 4 into the red equation, you're going to plug in 4.1 into the green equation. Do you guys see that? And that's going to be, I'm sorry, instead of plugging 4.1 into the red equation, you're going to plug 4.1 into the green equation, which is a lot easier to do. And it's an approximation. You'll be off a little bit, but it won't be enough to break up with your girlfriend, okay? So then this is going to be is it 4.8 here? Plus 64. Wow, that's a big number. Are you getting 68.8? Okay. Guys, is this the actual value or the approximate? All right, so let me write down, just so I don't forget. That's the approximate. Let me go find the actual. The actual value is 4.1 raised to the third power, and it's 68.921. Not bad for an approximation. So the actual value is 68.921. Let me just go ahead and talk about my error because you'll have to do it anyway. You subtract the two numbers to get your error. Okay, you don't have to worry about the negative sign. So if I asked you for your error, you get 1.21. On your test, I don't ask you for the actual. I may not ask you for the actual, and I may say, what's your error? You need to know that you have to calculate your actual. Does that make sense to get your error? All right. And then is this an over approximation or an under approximation? It's an under approximation, okay? You'd say under. If it's an under approximation, okay, what does that mean about my second derivative at 4? It is under approximation. It is positive. So you would say your second derivative is positive. Guys, look at my graph. Is my second derivative positive at 4? Yes, but be careful. If we were estimating -4, do you see my second derivative would have been negative, and it would have been an over approximation, okay? How are you guys feeling? Smarter? You are smarter, okay?